Hi, I am Teacher Daisy. Now, let's learn Form 4 Mathematics Chapter 8. Measures of dispersions for ungrouped data. In this chapter, you will learn 8.1 Dispersion. 8.1 Dispersion. Measures of dispersion of a set of data are quantitative measures such as range, interquartile range, variance, and standard deviation. The measures of dispersion give us an idea of how the values of a set of data are scattered about the mean. Dispersion is small if the data set has a small range and vice versa. If the data is clustered around the center value, the spread is small. The further the distances of the data values from the center value, the greater the spread. Example A. The table below shows the masses, in kg, of 20 pupils. State the difference in mass, in kg, of the pupils. Largest mass, equals 79 kilograms. Smallest mass, equals 47 kilograms. Difference in mass, equals 79 kilograms minus 47 kilograms, equals 32 kilograms. B. The diagram below shows a dot plot of the length, in cm, of a sample of several types of insects. State the difference in size, in cm, of the longest insect and the shortest insect. Length of the longest insect, equals 6.8 centimeters. Length of the shortest insect, equals 3.1 centimeters. Difference in length, equals 6.8 centimeters minus 3.1 centimeters, equals 3.7 centimeters. Compare and interpret dispersion of two or more sets of data, based on stem and leaf plots, and dot plots. Stem and leaf plot. A stem and leaf plot shows the distributions of a set of data. Through the stem and leaf plot, we can see whether the data is more likely to appear, or least likely to appear. Steps to plot a stem and leaf plot. We set the tens digit as the stem, and the units digit, as the leaf to plot the stem and leaf plot for the given data, 15, 16, 21, 23, 23, 26, 26, 30, 32. Example: the diagram below shows the marks obtained by a group of 36 pupils in an accounting test. From the stem and leaf plot, we find that the marks, which appear the most, are in the range of 40 to 49. Dot plot. A dot plot is a statistical chart that contains points located using a uniform scale. Each point represents a value. Example: the following data shows the scores obtained by a group of 20 pupils in a biology quiz. The diagram below shows a dot plot for the above data. Each point represents a value. The highest value is 8, the lowest value is 0, and most pupils get a score of 7. Compare and interpret the dispersion of two sets of data, based on a stem and leaf plot. When two sets of data are plotted using stem and leaf plots, we can compare the patterns of the two plots. Set 1, 2, 5, 8, 14, 18, 12, 22. Set 2, 3, 7, 10, 15, 28, 29. Compare and interpret two sets of data, based on dot plots. We can compare and interpret the shapes, the dispersion of points, the frequencies, and the values concentrated on the left, or on the right of the two sets of data. A mathematics quiz and a science quiz are held at SMK Bestery in conjunction of the Mathematics and Science Week. 20 pupils take part in the quizzes. The diagram below shows two dot plots of the scores obtained by the pupils. A. Which set of data shows a wider dispersion? Justify your answer. The dispersion in science quiz is larger, because it has larger difference in value. B. Which quiz has a higher difference in value? Science quiz has a higher difference in value, that is 7. C. Between the scores of science and mathematics quizzes, which pupil's achievement is better? The pupils score better in mathematics quiz, because most of the values are concentrated on the right of the dot plot. Measures of dispersion determine the range, interquartile range, variance, and standard deviation as a measure to describe dispersion of an ungrouped data. The range of an ungrouped data is the difference between the largest and the smallest values. Range equals largest value minus smallest value. Example, given a set of data 34, 23, 14, 26, 40, 25, 20. Measures of dispersion determine the range, interquartile range, variance, and standard deviation as a measure to describe dispersion of an ungrouped data. The range of an ungrouped data. Determine range from the frequency table. Example, the table below shows the scores obtained by a group of pupils in a chemistry test. Determine the range of the above data. Solution: range equals 8 minus 2 equals 6. Determine the interquartile range of a set of ungrouped data. The interquartile range divides the set into 4 equal parts, or quarters. The 3 values that form the 4 divisions are called quartiles. First quartile, Q1, second quartile, median, Q2, and third quartile, Q3. The interquartile range is the difference between the third quartile and the first quartile. Example, determine the interquartile range of each of the following sets of data: A, 4, 4, 6, 8, 10, 13, 15, 16, 20, 22, 23. Interquartile range equals 20 minus 6 equals 14. B, 11, 14, 14, 17, 19, 20, 20, 21, 22. Interquartile range equals 20 plus 21 over 2 minus 14 plus 14 over 2 equals 6.5. Example, determine the interquartile range of the following frequency table. Cumulative frequency of a given data is determined by adding its frequency and all the frequencies before it. Q1 equals the 1/4 times 44 value equals the 11th value equals 4. Q3 equals the 3/4 times 44 value equals the 33rd value equals 6. Interquartile range equals 6 minus 4 equals 2. Determine the variance and standard deviation for a set of ungrouped data. Variance. Formula for variance. The variance is the average of the square of the difference between each data and the mean. A high variance indicates that the data points are very spread out from the mean and from each other. A small variance indicates that the data points tend to be very close to the mean and to each other. If given frequency table, the formula mean, and the formula for variance. Standard deviation. The standard deviation is the square root of the variance and also measures the dispersion of a data set relative to its mean. The standard deviation is the average distance of each data point from the mean. Taking the square root returns the same units as expressed in the original data. Example, determine the variance of the set of data 2, 4, 5, 5, 6. Mean equals 2 plus 4 plus 5 plus 5 plus 6 over 5 equals 4.4. Variance equals 2 minus 4.4 squared plus 4 minus 4.4 squared plus 5 minus 4.4 squared plus 5 minus 4.4 squared plus 6 minus 4.4 squared over 5 equals 1.84. Example: the table below shows the number of books read by a group of pupils in a particular month. Calculate the variance and standard deviation for the number of books read. Solution: mean equals 3 times 0 plus 5 times 1 plus 8 times 2 plus 2 times 3 plus 2 times 4 over 3 plus 5 plus 8 plus 2 plus 2 equals 1.75. Variance equals 3 times 0 minus 1.75 squared plus 5 times 1 minus 1.75 squared plus 8 times 2 minus 1.75 squared plus 2 times 3 minus 1.75 squared plus 2 times 4 minus 1.75 squared over 20 equals 1.2875. Alternative method 1, variance equals 3 times 0 squared plus 5 times 1 squared plus 8 times 2 squared plus 2 times 3 squared plus 2 times 4 squared over 20 minus 1.75 squared equals 1.2875. Alternative method 2, mean equals 35 over 20 equals 1.75, variance equals 87 over 20 minus 1.75 squared equals 1.2875. Standard deviation equals square root of variance. Square root of 1.2875 equals 1.1347. Advantages and disadvantages of various measures of dispersion. If there is an outlier or extreme value, the interquartile range is more appropriate to show the distribution of the data. Example: calculate the range, an interquartile range, of the set of data 10, 11, 11, 14, 18, 20, 21, 21, 25, and 40. Determine the most appropriate measure of dispersion to be used to measure the distribution of the data set. Solution: range equals 40 minus 10 equals 30, interquartile range equals 21 minus 11 equals 10. Interquartile range is the most appropriate measure of dispersion because the existence of the outlier, 40. Standard deviation is usually used to compare two sets of data. In general, a low standard deviation indicates that the data is dispersed close to the mean, while a high standard deviation indicates that the data is dispersed far from the mean. Example: the table below shows the achievements of 2 pupils in 5 physics tests. One of the pupils will be selected to represent the school in a physics quiz competition. Determine who is eligible to be selected and justify your answer. Solution: Iman, mean marks, equals 40 plus 70, plus 90 plus 85, plus 64 over 5, equals 69.8. Standard deviation equals square root of 40 squared plus 70 squared, plus 90 squared, plus 85 squared, plus 64 squared, over 5, minus 69.8 squared, equals 17.67. John, mean marks, equals 80 plus 65, plus 73, plus 58, plus 73 over 5, equals 69.8. Standard deviation equals square root of 80 squared plus 65 squared, plus 73 squared, plus 58 squared, plus 73 squared, over 5, minus 69.8 squared, equals 7.574. John will be selected to participate in the physics quiz competition. The standard deviation of John's scores is lower because John's achievement is more consistent. Construct and interpret the box plot for a set of ungrouped data. Box plot shows the distribution of a set of data based on 5 values, namely the minimum value, first quartile, median, third quartile, and the maximum value of the set of data. It can show whether the set of data is symmetric about the median. Types of box plots. Construct a box plot. The box plot is constructed on a number line. The data below shows the marks obtained by 15 pupils in a Chinese language test. For the set of data, determine the values shown in the table below first. Minimum value 35, first quartile 45, median 57, third quartile 68, maximum value 75. Thus, the box plot for the above set of data is as follows. For the box plot, state 1. The median. Median equals 52. 2. The first quartile. First quartile equals 35. 3. The third quartile. Third quartile equals 64. 4. The interquartile range. Interquartile range equals 29. 5. The minimum value. Minimum value equals 18. 6. The maximum value. Maximum value equals 80. 7. The range. Range equals 62. Effect of data changes on dispersion. Effects on the measures of dispersion when each value of a set of data is added or subtracted by a constant. There are no changes to the measures of dispersion when each value of a set of data is added or subtracted by a constant. Example: the data is changed uniformly by adding or subtracting a constant. When each value of a set of data is added by 2, 1, the whole dot plot is shifted to the right by 2 units. Where the dispersion remains unchanged. 2. Original score range equals 15 minus 8 equals 7. New score range equals 17 minus 10 equals 7. The range of both sets of the data is the same. Effects on the measures of dispersion when each value of a set of data is multiplied or divided by a constant. A. When each value of a set of data is multiplied by a constant k, then 1. New range equals k times original range. 2. New interquartile range equals k times original interquartile range. 3. New standard deviation equals k times original standard deviation. 4. New variance equals k squared times original variance. B. When each value of a set of data is divided by a constant k, then original range, 1, new range, equals original range over k. 2. New interquartile range equals original interquartile range over k. 3. New standard deviation equals original standard deviation over k. 4. New variance equals original over k squared. The data is changed uniformly by multiplying or dividing by a constant. When each value of a set of data is multiplied by 2, 1, the dispersion of the whole dot plot becomes twice as wide. 2. Original score range equals 5 minus 1 equals 4. New score range equals 10 minus 2 equals 8. The range of the new set of data is 2 times the range of the original set of data. When each value of a set of data is multiplied by a constant k, new range equals k times original range. Effects on the measures of dispersion when an outlier is added or removed from the set of data. When an outlier 9 is added. A. Range 1. The dispersion of the whole dot plot becomes wider. 2. Original score range equals 5 minus 1 equals 4. New score range equals 9 minus 1 equals 8. The range of the new set of data becomes larger compared to the range of the original set of data when an outlier is added. B. The terquartile range, less affected when an outlier is added or removed from the set of data. C. Variance and standard deviation, they increase significantly when an outlier is added into the set of data. If the difference between the new value of the data and the mean is small, then the new standard deviation will be smaller and vice versa. Example: given a set of data 4, 6, 7, 7, 9, 11, 12, 12, calculate the standard deviation of the set of data. Hence, calculate the new standard deviation when A. 4 is removed, B. 18 is added. Solution: mean equals 4 plus 6 plus 7 plus 7 plus 9 plus 11 plus 12 plus 12 over 8 equals 8.5. Standard deviation equals square root of 4 squared plus 6 squared plus 7 squared plus 7 squared plus 9 squared plus 11 squared plus 12 squared plus 12 squared over 8 minus 8.5 squared equals 2.784. A mean equals 6 plus 7 plus 7 plus 9 plus 11 plus 12 plus 12 over 7 equals 9.143. New standard deviation equals square root of 6 squared plus 7 squared plus 7 squared plus 9 squared plus 11 squared plus 12 squared plus 12 squared over 7 minus 9.143 squared equals 2.356. When the value that has a greater difference from mean is removed, the new standard deviation will be smaller. B new mean equals 4 plus 6 plus 7 plus 7 plus 9 plus 11 plus 12 plus 12 plus 18 over 9 equals 9.556. New standard deviation equals square root of 4 squared plus 6 squared plus 7 squared plus 7 squared plus 9 squared plus 11 squared plus 12 squared plus 12 squared plus 18 squared over 9 minus 9.556 squared equals 3.974. When the value that has a greater difference from mean is added, the new standard deviation will be larger. Compare and interpret two or more sets of ungrouped data based on the appropriate measures of dispersion. Example: the table below shows the time taken by 20 employees in 2 factories to complete a job. Calculate the mean and the standard deviation for the time taken to complete the job. Hence, determine which factory's employees are more efficient to complete the job. Justify your answer. Factory A, mean equals 5 times 3 plus 6 times 2 plus 7 times 9 plus 8 times 2 plus 9 times 4 over 3 plus 2 plus 9 plus 2 plus 4 equals 7.1. Standard deviation equals square root of 5 squared times 3 plus 6 squared times 2 plus 7 squared times 9 plus 8 squared times 2 plus 9 squared times 4 over 3 plus 2 plus 9 plus 2 plus 4 minus 7.1 squared equals 1.261. Factory B, mean equals 5 times 1 plus 6 times 5 plus 7 times 7 plus 8 times 5 plus 9 times 2 over 1 plus 5 plus 7 plus 5 plus 2 equals 7.1. Standard deviation equals square root of 5 squared times 1 plus 6 squared times 5 plus 7 squared times 7 plus 8 squared times 5 plus 9 squared times 2 over 1 plus 5 plus 7 plus 5 plus 2 minus 7.1 squared equals 1.044. The employees in Factory B are more efficient because its standard deviation is smaller. The concept map form for Chapter 8 is as below.
If you find this video helpful, don't forget to like, share and subscribe our channel. And if you got any question can comment below. Thanks for watching.